what we're going to do now is take a look at the relationship of similar polygons and their perimeters, their areas, and their volumes. So, if we have two similar polygons here that are two-dimensional, we have a triangle ABC, which is similar to triangle EFG, and their scale factor is given to us as a ratio of 3 to 5, or you can write it as a fraction. And most of the time we write them as a fraction when we do this work. Without knowing the other sides, we are able to say that the perimeters of the two similar polygons have a ratio of 3 to 5 as the same as the scale factor. So the perimeter of triangle ABC over the perimeter of triangle EFG is equal to 3 to 5. Now, the ratio of their areas will be the square of their scale factor. So we know that the ratio of these two polygons is 3 to 5. So the area of triangle ABC over the area of triangle EFG is going to be 3 squared over 5 squared, which means 9 over 25. Well, let's see an example of this so that you have a good idea of what's going on. So we have given two similar polygons. We have a rectangle, and it is similar to the larger rectangle at a ratio of 6 to 9, which reduces to 2 to 3. Okay? So that is the ratio of the two similar rectangles. Now the ratio of their perimeters, their perimeter is 6 plus 4 is 10 times 2 is 20, so the perimeter of the smaller rectangle is 20. The perimeter of the larger rectangle is 9 and 6 is 15 times 2, which is 30. So the ratio of their perimeters, which is 20 to 30, reduces to 2 to 3, which is the same as the ratio of their scale factor. Now, the ratio of their areas, the ratio of the area of the first triangle, which is 6 times 4, is 24. And the rectangle's area of the larger rectangle is 6 times 9, which is 54. So 24 over 54 will reduce to 4 over 9 if you divide by 6. 6 times 4 is 24. 6 times 9 is 54. So 4 over 9 is the ratio of what the scale factor was, 2 squared over 3 squared. So that's how you can see that it works. Okay, so now let's talk about volume. With the 3D objects that are similar, the ratio of their volumes is equal to their scale factor cubed. So, let's take a look at that. If I give you two cylinders, and I'm telling you that they're similar because that's given to you, the radius is 3 for the first one, and the height is 6. The radius is 4 for the second one, and the height is 8. So their ratio is 3 to 4. Okay, very good. So their ratio is 3 to 4. Now, their volumes should be in a ratio of 3 cubed over 4 cubed, which would be 27 over 64. Okay, so let's take a look at that. Let's see if that happens. All right, well, the volume of our first cylinder is pi 3 squared times 6, because that's pi r squared times the height, and that is going to give us 54 pi. The volume of the larger cylinder is 4 squared times 8 times pi, which is 128 pi. And that gives us 54 pi over 128 pi when you take the two volumes and put the smaller one over the larger one. Well, that will reduce. If you reduce this, the pi's will cancel out. And if you take 54 and you divide it by 2, you get 27. If you take 128 and divide it by 2, you get 64. Well, isn't that 3 cubed over 4 cubed? Because 3 times 3 times 3 is 27, and 4 times 4 times 4 is 64. And so we have it, folks. And with that, good jobby.